Okay, class, we're about to finish up section 4.6. Now, we're on example 2, and we're going to substitute in this value for y. Y is 5/9. We'll put that in parentheses. Plus 2 times x is 7/12. Now, we will have 5/9 plus, we will make this 2 over 1, times 7/12. So this will give us 5/9 plus 14 over 12. Now we can simplify this 14 over 12, but first let's just go ahead and find the common denominators. We could take 9 and 12. 9 breaks down to 3 times 3, and 12 breaks down to, we add 2 times 6 and 2 times 3. So the prime factorization of 9 is 3 and 3. Prime factorization of 12 is 2 2s and a 3. Now the only thing they have in common is one set of 3's. So we could bring down the 2 2s here. We could bring down the one set of 3's that match up, and then the 3 that's by itself. So that would give us a common denominator of 36. So we'll write our common denominator of 36. Now we ask ourselves, we're comparing 9 to 12. We ask ourselves, what does 12 have that 9 does not? Now you notice they both have a 3, but 12 has 2 2's. So we know 2 times 2 is 4. So we will multiply this fraction by 4 over 4, and that will give us 20 over 36. Now we ask ourselves, what does 9 have that 12 does not? Now 12 has 1 3, but 9 has 2 3's. So we will multiply that numerator and denominator by 3. Now 12 times 3 is 36. 14 times 3 is 42. So now we add them. 20 plus 42 is 62 divided by 36. Now we want to simplify this. So we do the prime factorization. We add a prime factorization of 62, prime factorization of 36. Now, let me scroll down here. Just for a little bit more room. Okay, now we could factor out 2 times 31 for 62, and then 36, we already have the prime factorization of 36, which is 2 2's and 2 3's. So now we substitute that. 62 in our numerator, we had 2 times 31. In our denominator, we will add 2 times 2 times 3 times 3. These two simplify out, and you will be left with 31 over 2 times 3 is 6 times 3 is 18. And since we cannot do anything else with this, that is our final answer. We do not have to write it as a mixed number. Okay, now we go to section C, complex fraction. A complex fraction is a fraction in which the numerator and or denominator contain other fractions. You can work them out just like you would any other order of operation. Now, this is what happens here. You basically have a fraction divided by a fraction. And this is how we could do it. We could write the top fraction, which is 3/4, divided by the bottom fraction. So now we could do this like any other division problem. It would be 3/4 times the reciprocal, which is 8 over 7. Now we write out the prime factorization. We had 3, which is prime. And in previous problems we did, as far as examples, we know the prime factorization of 8 is 2 times 2 times 2. Now the prime factorization of 4 is 2 times 2. And since 7 is prime, we'll write times 7. Now we have this 2 and this 2, this 2 and this 2. They simplify out, 2 sets of 2's. So now we multiply. 3 times 2 is 6, and then our denominator is 7. So that is our final answer for number 1. Now we move to number 2. You would take 3/5 divided by 3/7. So you add 3/5 times 7 over 3. Now, we'll multiply this. These are all prime numbers. So we add 3 times 7 over 5 times 3. The only thing they have in common is these 3's here. So now they simplify out, and we're left with 7 in the numerator, 5 in the denominator. And that is it for that problem. And we're done.